Hey, welcome to Automat Live Coding. This is the stream where we write Automat. This is Automat. I can restart it. So when it loads, you will see what we have been doing during the last stream, the loading animation. Pretty. Specifically, we changed the colors and we fixed it so that it works using a new rendering infrastructure that we have. Anyway, this application, this is a desktop automation application similar to AutoHotkey, but it's based on those objects that can be arranged together to do stuff. Like I could create a small pipeline which, for example, will press a mouse button for 1 second. So mouse is pressed down for 1 second, then it's released, and we can do this every 10 seconds. Yeah, I can start this, and maybe I can move my mouse here so you can see. Yeah, a mouse was pressed and released. So it quickly pressed the mouse for me. The point of this environment is to automate repetitive actions in games, like gacha games. There are plenty of games which force the players to repeatedly perform the same action over and over, sometimes with small twists. Anyway, I think this kind of games, quite often they are fun, they are nice to play, but this element, this repetitive element could be removed. So this is what Automat does. It helps with repetitive UI actions. Here you can see an example of a slightly more complex macro. This is a macro that automatically buys ingredients from vendors in Skyrim. It uses some fancy features like OCR, so Automat can recognize text within other apps. As you can see, I can move this window around and recognize different pieces of text, like the length of track or current playback position. And I can use this in the macro. Oh, that's interesting. Yeah, so we switched to a new kind of rendering system, and where we have multiple threads recording commands. And it seems like it has some weird side effects. I thought we fixed all of them. It seems like maybe this is the last one. It should be easy to fix, hopefully. Anyway, the plan for today is actually to change the way we render this environment a little bit. So this environment is composed of objects. Each object, maybe I shouldn't use the term object, widgets, let's call them widgets. So each widget has a texture. A texture is drawn first by Automat as a series of commands. Those commands are very similar to vector graphics. They describe basically how to the shape, the textures. They can include bitmaps, like actual textures. They can include shaders, which will affect the shading of the shape. So they kind of allow us to draw pretty much everything that can be drawn on a computer. So we have that. Once we have this sequence of drawing commands, we have to translate it into a language which can be understood by a GPU. This is something that we've been doing over this week. Yeah, I think, I don't remember when we started. About a week. It took us about a week to switch to this new rendering mode. It works smoothly now. It improved performance actually. So now all of the objects, we get much more stable FPS right now. Maybe not that much more stable. But the idea here is that now we are doing this translation from our vector graphics language to Vulkan commands in multiple threads. It was a very expensive part of rendering, so now that it's multi-threaded, can basically divide the cost by number of cores in the CPU. And it's not something that we are doing all the time. This is very... This is highly irregular, this rendering, because most of the time when you're looking at Automat, nothing updates. So when nothing updates, we are not re-rendering anything. Like when this object is actually being updated. So this one is being re-rendered, but this one, nope, this one, no. None of them is re-rendering. Only this thing here. So what are we going to do today? There is one more thing which we are doing wrong, which I want to correct now. So whenever we draw a frame, we go through the tree of widgets which are visible on screen, and we are deciding which ones to render in a current frame and which ones should be rendered using the previous frames. Oh, it crashed. Very interesting. Let's see, we have 3 extra threads for assembly. Anyway. So when we decide which widgets to render in the current frame and which widgets to not render, we send all of them to the rendering system, and the rendering system does everything it can to render the current frame as quickly as possible and to present it immediately to screen. And then it starts rendering the background objects. And the background objects are... So theoretically they should be rendered in background. The problem is that when we display the next frame, we actually invoke a special command called sync. So we are actually asking the GPU to finish its work and tell us that it's finished. It's not great, because we are scheduling stuff that should be happening in the background, and then we are telling GPU, hey, wait, tell us when you're done. So we have to change that. We have to make it possible for the GPU to inform us that it finished rendering the frame, and we don't really need to care about the stuff that's rendering in the background. We can ignore it. So we will change the way we synchronize rendering. That's the plan. And maybe I will actually start by fixing this timeline issue. Let me fold everything. So timeline is a super complex object. Somewhere here we should have the function that draws this. Inset in the wooden case. Okay, here we have this LCD screen. Okay, I think this could be this function. Start this. Okay, why is the issue not happening anymore? Come on. Okay, I have to zoom in. Okay, let's ignore this. Eventually it will happen again, then we will fix it. So let's switch to renderer. And let's find all of the places where we do sync. Synchronization, this is different synchronization. This one. Okay, so what we could do, we could keep track of the number of widgets which are being rendered. Let's set this to 0. So whenever we do this, whenever we do insert recording, can increment this counter. Then we insert the recording, and when it finishes, this is a finished proc. We should probably also avoid this submit. Okay, when it finishes, we want to do this emplace, and we want to decrement the counter. And I think to make this more self-contained, this incrementation should probably happen within insert recording. So now we can see that when we insert this, we increment, when we finish, we decrement. And this callback tells us whether it actually worked. We are not doing this right now. We are not using the result. So if rendering fails, I don't know why it would fail, but it's possible. We ignore this. Anyway. What is that? Okay. So this is a so-called spin lock. It basically tells our thread to just wait. Because we don't want to wait for everything. We only want to wait for those that finished. Actually, maybe we don't need... no, we do. So we really need to call this repeatedly because there is no API that would allow us to wait for a callback, and then once we get this callback, to exit. Yeah, okay. Let's see how this works. Okay. It seems like nothing is broken. So theoretically, it should be faster now. Oh no, it's not. There's one more thing I forgot about. We should only increment this if we should only increment and decrement this if we are rendering in the foreground. Yep. So now I should be getting smooth 60 FPS, even though this background stuff can be lagging behind. Okay, let me see some numbers. I want this number to be large, because it means we are actually spinning fast. Yeah, it is. Oh wow, this is great. I want to see how this works on Windows. So I have a Windows laptop, which is much slower, right? It doesn't have a beefy dedicated GPU. So this essentially allows Automat to be robust to single super slow jobs. Pretty much, yeah. Okay, yeah, I want to see how this works on Windows. I will submit it with the log message. Actually, maybe we have more submits. Let me see. We have submit here. Submit here. Okay. That's decent. We can remove more of those, actually. I'm not sure how it will affect performance. Let's see how it's implemented. Maybe there is a better way to do this. This queue manager is the important one. Okay, this is weird. Repeat till we find a submission that has not finished yet. All the others afterwards are also guaranteed to not have finished. I actually thought that the tasks can finish kind of asynchronously. So a task which is submitted later can finish earlier. Maybe I need to create multiple contexts, one for foreground and one for background jobs. Possibly. How do I create a context? Actually, no. Here, when we finish with some background jobs still in the queue. Let me run the test, because we wrote a special test to exercise this problem. our window, our test case thinks it's still loading. No, let me fix this. So loading animation. I will delete this global variable. Yep. Okay, our draw guard should be movable. And now we can move it. It's hard to design this guard. Okay, I can use a different operator. This is an interesting constructor. Can give it a function and a value to move. Anyway, I will just define the assignment operator. I just wanted to disable the loading animation so that it doesn't appear in the test. It was silly. Okay. The renderer is still slow. I actually wonder why. Why that is? Why is it so slow? I think I know. Okay, so we have this line here. When we send the job to the renderers, we increment the discounter, and when we receive those jobs back, we basically wait before we receive all of them back. We don't really need to wait for all of them. The overflow, we don't care about that. I don't want to do too many things at the same time, so I will submit some of them. This loading animation change. And this, and this. Okay, so okay, if I go back to my test, this renderer test is injecting artificial slowness into rendering using this slow drawable. But I could also create something called slow paint that would just stress the fragment shader to slow down the rendering. By computing fractal or something like that. I just want to see if we can use the shader to shade the circle. It is red, great. Now let's insert something very, very slow here. Can remove this slow drawable. Don't really need it. Okay, so we have a rotating circle, which for some reason is rather choppy. Okay, it looks like this is called every 60 times per second. The movement seems choppy. Doesn't look like 60 times per second. I think we will need some better debugging tools to figure out what's happening here. We start by doing this. Okay, I need to enable both. See anything? I have a theory. I think I need to take modulo here. Because it's probably converting to float, and my computer has been up for many days now. Yeah, now it's smooth. This is how it should look. Okay, this is a relief, because it means the issue is just in the test, not with our renderer. Renderer is still decent. So, just to be sure, I want to re-enable this eventually, because we want to be resilient to slowly drawing objects. So yes, definitely it will be enabled. But yeah, I want to insert something heavy here. So let's look at shader toy. Let's grab some Mandelbrot. I think I should create an adapter for shader toy shaders, because they use a lot of you can copy this stuff in full. It's definitely going to fail because we haven't defined those parameters here. When there is this conditional compilation, what?
EXP says,
does computer science have a lot of job opportunities?
Yeah, I would say so. It's pure computer science alone is probably less economically useful than computer science connected with some other area of life, like medicine or manufacturing, this kind of stuff. Yeah, and then it's incredibly valuable. Yeah, computer science is the automation engine of the world right now. Wherever there is some work to do, it typically can be made, repeatable. Yeah, absolutely. It may be strange what I'm doing here, but I'm rendering at a very small scale.
I know coding is hard, but I'm going to start learning this kind of thing my first year. Any tips, man?
Yeah, it's not that hard. It's a little bit like learning a foreign language, right? If you learn a foreign language at the right age and you kind of sit, if you just spend a lot of time, staring at some, I don't know, French, Italian, any language, it starts to click. So you can think in a different language, speak in a different language. It's not that crazy if you spend some time doing this. So it's just a function of mental effort. If you spend a lot of mental effort trying to figure out, coding, programming, eventually it becomes easier and easier and easier. Eventually it stops being work, really. There is a shade. I don't know if you can see this rectangle, but it's not entirely white. So I changed the time a little bit. I think if I decrease this a little bit, we will see more of the fractal. Unfortunately not. Okay, I think we need a point from -1 to 1. Let's do this. It's a different way to solve our issue. Okay, I will change this I time to a proper uniform. I'm going to shift this p-value. Why is this white? Okay, the thing is, this is a local coordinate. What? Sorry, what? Suddenly it started working. And this local coordinate has a very small value. Anyway, I want to slow down this rendering. So when we render Mandelbrot, there is this loop that we can just make slower. So let's make it 10 times slower. even slower. It's still rendering very fast. I have a beefy GPU, but I don't know why it sometimes just shows widescreen. Oh, actually I don't know. I have no idea why it's sometimes white. I could possibly remove this exit condition. Somehow it still renders very fast. You know what? I will get rid of this. Completely. Time, we can keep time. Okay, so this is my slow shader. It should output just noise, just RGB noise. Now it has to be slow. There's no way this runs fast. Okay, I think we managed to do it. Now the rendering is very slow. Okay, we can probably make it actually faster. Oh wow, it's so slow that it's locking up my PC. But the interesting thing is that we don't seem to be correctly attributing the speed. Issue. Cursor is not responding. Okay. I will say that we succeeded in making the rendering slow. It's actually so slow that it crashes my GPU. Yeah, so this is a fun thing. So if you put this in a web shader, you can crash probably the browser. There we go. Okay, now each frame takes about 2 frames. So we can slow this down even more. Let's make this 2000. Nice. Okay, now the GPU is used in 100%. It's just computing this shader. It's totally insane shader. And Chrome is also using 100% of CPU. Oh, it's because of that. Because of this Mandelbrot here. Okay, I don't know why we are saying that it takes 0.1 millisecond. It's definitely not 0.1 millisecond, this widget. It is probably because we are only accounting for the CPU time, and CPU time is actually very fast. It's using a lot of time on the GPU. So let's include the GPU time. Let's record this time. So I think maybe it would be better if we put this GPU start after insert recording, but that would require some very weird synchronization. So I want to avoid this. Okay, we are doing better actually. We're still not perfect because this widget renders in 70 milliseconds and the top level widget, it refreshes every 30 something milliseconds. So we can actually divide the latency in two. But it seems like we are never quite able to have the widget render over multiple frames. I think this would require multiple contexts. Because we have to do it, right? Yeah, our current imperfect setup, it reduces latency by 2. So if we have object that takes a second to render, we will render a frame every half a second. Yeah, We want to do it better. And also this drawable, we also want to make this kind of totally robust. You know what, I will make a short break and then we will come back. And I think when we come back, I think we should start. Like, there are two places where slowness can impact us. First, there is the draw function. When we call widget draw, it can be kind of expensive. So this is one thing. And the other thing is the GPU part, GPU shader. I think largely this is the part which hurts us. Not super sure, but I actually think both of them hurt us a little bit. So we need to make the rendering resilient to both of those bottlenecks. Okay, I will be back in a couple of minutes.
PIT says.
Oh.
Okay. So, the change in the test. Let's submit this. What when I look at this, it really feels kind of wrong to me. Because kind of the point of Vulkan is that I have command queue, I put the stuff on the command queue serially, and the GPU can execute it in arbitrary order, like only caring about semaphores.
Bro, did you ever try it? SDLL?
Yeah, I did. SDL used to be the main way for writing small apps. I think nowadays SFML is slightly more popular, but SDL, I don't know the new SDL, I know there is SDL 3 now. I don't know what they added in the most recent version. Yeah, it's the bread and butter of game development. There is no reason not to use SDL. I want to look more at this function.
SFML is not kinda compatible with phones, ARM architecture, and all.
Interesting. I really thought that SFML was like a drop-in replacement for SDL. But yeah, WebAssembly is really nice for SDL. This is how I usually use it. This is my main way of writing stuff in WebAssembly. Okay, I'm looking how Skia talks with the GPU, and it seems that there is just one queue manager per context. Can there be multiple queue managers? I don't think so. And the queue manager, what does it contain? Oh, there is some comment. Speaking of SDL, one thing I really love about SDL is the ability to substitute it. It has a very interesting linking story where you link it, I don't know if you link it dynamically or statically, but there is a way to do a lot of replacement at runtime. If you have an old game which was built with SDL and you want to run it on a new hardware with like totally different operation mechanisms, for example, different controllers, you can do that with SDL because SDL has those hooks that allow you to replace the input handling methods or the display methods that the game uses. So it's really nice, it's really stable. I think this is like the nicest like abstraction layer for games. If you're like creating a game and you care about this game running in 10 years, SDL is really good for that.
Fabulax says,
Hey everyone,
PRET
Hey.
says,
I'm not getting this code, please. Explain it to me, please, bro.
Okay, let's keep looking at this queue manager. Okay, when I read the comment, it says that this queue manager manages all command buffers. So it means that there can be many of them. And hopefully they can be... I hope we don't have to do this waiting where they have to kind of finish in order, because this is the worst part. I want to have a command that runs and runs and runs in the background. The GPU can run stuff in the background. We don't have to worry about this. Okay, so we can add recordings, we can add tasks. I have no idea what are tasks. It's probably a private thing, yeah. It's private. Probably some deferred stuff. Interesting. Now, this queue manager, by the way, is also private, so it's not part of the public API. There's the virtual tick function. Maybe this can do something. I don't know. I guess this is where we are calling callbacks. Okay, and this is the only way where we are destroying this outstanding submission. So it seems that Skia really wants to execute stuff in order, even though it shouldn't need to be executed in order. Okay, we have to have multiple contexts. How does it work? So we're calling this vulkan paint every frame. We're calling this get back buffer canvas. Yeah, I guess we can just create multiple contexts here. So we'll have this regular context that we use for rendering frames, and we will also have one for rendering stuff in the background. I'm not sure if I can reuse the same queue, the same queue index. Probably not. Probably not. Okay, so this is just a pointer. So it doesn't look like this is allocating a separate queue. Maybe this can be the same. Okay, still works, doesn't crash. So there are just a couple places where we're using this context. Should not be necessary. So going to our renderer threads. I mean recorder threads. Right now they get a recorder which records using this foreground like this main context. I could pass two recorders there. So now each recorder thread has two of those recorders, and we are submitting. Actually, no, we are creating the recording using the right recorder. Now we also need to insert it correctly. This. Yeah, it locks up in a very weird way. I'm not surprised. Okay, we need to do one more thing. We need to also check for background work completion. Okay, we are rendering. Let's enable debugging. Okay, we are still having this lockstep execution. So here's an example frame. We have finished recording root widget and slow widget. Current frame is going to include only root widget, and slow widget goes into overflow. So we are printing this begin submit here. Then we got finished.
Hollowenter 427 says,
Hey man, what are your thoughts on lead code?
Hey, I enjoy this. It's a fun hobby, like doing crosswords or Sudoku. Some people, I think the only people who dislike lead code dislike it because it's often used as a proxy for during interviews, as a proxy for the skills of the candidate. It's hard to fake. I guess that's why it's so popular. But it's also not a perfect, measuring stick. But abstracting from the interviews, yeah, it's a very cool. It's a very cool hobby. And very practical. Because a lot of things that we are doing, like for example here with the rendering pipeline, there are ways to optimize this using the right algorithms. This is essentially a graph. Like what we are doing is just maybe we are not so much playing with the algorithms, we are mostly resolving bugs and misunderstandings between different pieces of the software. But there is some algorithmic layer there, very deep in this Vulkan thingy. There is the DAG, essentially, a graph of jobs that have to be executed. And what we're trying to do is we are trying to optimize this graph to make sure it fits within a single frame.
Ooh, okay, that's cool, thanks.
Yeah. It's too bad that this algorithmic theory is obscured by the just issues and mismatch between different components, what they produce, what they expect. Yeah, I guess that doesn't matter. Okay, so do we print frame packing? This is last step of pack frame. Okay. So I want to understand what's happening here.
How do you learn all this?
I should probably write this down, but the best strategy for learning is you start with a tutorial for something, whatever you want to do, but you don't create grandiose plans for what you want to create. Instead, you learn what the tutorial tells you, and then you try to apply this in many different ways to the extreme. Like, you look at the first lesson in the tutorial and you try to build something out of this, and you play with it like a lot. And only when you actually created a couple example programs using the first lesson of the tutorial, only then you move to the next lesson, and then you play with the next next function that it teaches you. But after each step, there is this necessary experimentation period where you experiment with this new thing.
Like, I know Python and stuff, but nowhere near this much smarter.
It comes with time. It's just a function of spending a lot of time staring at code. It's kind of like music, People who play a lot of music eventually kind of get good at this. It's just a matter of practice, repeating the same stuff. Yeah, and programming is just like pretty much any other skill. It's like playing football, right? You just need to do this a lot. You need to train a lot to get good at this. And the same with lead code, right? Lead code is kind of like trick shots. It's not maybe the most practical skill on a football field, but sometimes, very rarely, you get opportunity to use it, and then it's nice to have it. Okay. I'm looking at the log. So this is the log of our rendering process, and it tells us what happens in what order. And this is exactly what we need. So we can start, for example, here, like we did. We are starting with blank slate. So both widgets have finished rendering, and we want to render them. So we are deciding that, okay, we want to refresh the root widget synchronously, and the slow widget we want to render in the background.
Cool. Also, I noticed you have a PhD in machine learning. Do you think making large language models that can generate real text on our home laptop would be possible using PyTorch or something similar?
Yeah, I mean, so the type of language models that I used to work with were... It was just before the... So transformers came out, but transformers were still not ubiquitous when I was doing this. I still used recurrent networks. And recurrent networks are, compared to transformers, they are ridiculously fast. They are just absurdly fast. They generate token per microsecond. Like, you can easily get 1,000 tokens, or even more, like tens of thousands of tokens per second, or even more than that on a GPU. But they are very stupid. The models I worked with were very, very small. And yeah, absolutely they should be used on computers, on local computers. Hopefully within Automat we can embed an LLM. There is some deployment issues around this embedding, so we're not doing this yet, but we will get to this once we get some other things in order. You know, you can run Olama. Locally.
So I can make my own GPT.
Yeah. GPT-2 is a relatively small architecture. GPT-2, even though it's a transformer, it can be trained on a single consumer GPU. So that one is entirely, within single machine capabilities. Maybe there will be more fine-tuning. I don't know how it will play out in the end. I'm very optimistic though with language models. They are like my absolutely favorite approach to artificial intelligence. They are, compared to, for example, expert systems or evolutionary agents, like agents which are trained, through virtual evolution. Language models are totally interpretable. They are so transparent. You can literally look at their thought process and see what they are doing. Yeah, and you can easily play with them. Like, they work on probabilities. You have output probabilities of words, and you have feature vectors for words, which makes it like, if you can think of a crazy thing that you can do with, language model by, I don't know, for example, averaging the meaning of words, or like stretching the vector space where words are located, you can do it and see how it works. It's very easy to work with this representation. It's not a black box. This is what I love about it. And it fails in fun ways, in ways very similar to how we fail. For example, the hallucinations. This is just incredible how similar they are to confabulation, like when somebody is forced to recall an information and they don't remember this information. It's incredible how similar it is to language model hallucinations.
Cool. Where do I start learning ML?
I guess university would be a good place. Sign up for computer science. And if you're playing with Python, right? You mentioned that you do a lot of Python, so you can get PyTorch. And they probably have a tutorial for how to use it. Yeah, PyTorch tutorials. It tells you essentially how you can build neural networks in Python.
Mill goes under data science, I'm assuming, right?
Yeah, it probably depends on how so each kind of academic system has its own traditions, its own kind of structure. Yeah, you will have to look around and see how it looks for you. But yeah, university is very good. They teach you also the stuff which is not popular. The unpopular stuff is still relevant. I mean, it comes back like a boomerang. Like neural networks, for instance, they were unpopular a couple of years ago. Like maybe not 10 years ago. 10 years ago, they were already kind of becoming popular again.
Won't be on any day or Sunday they were.
TTS had a stroke, don't worry about it. So neural networks are a good example because they were popular like a long time ago. Then they became totally uninteresting. People realized that, hey, you can do much better with decision trees. You can do much better with like support vector machines. They are way faster, way more reliable, and easier to interpret because neural networks were also black boxes back then. And some new techniques came out. The vector representations for words, the transformers, and together, they made neural networks interesting again. But I think those other approaches, they will come back eventually. There is this thing in engineering that usually the most efficient system is like a mixture of different techniques, where each technique is only applied where it's most useful. So I think eventually the neural networks will have to be married to all of the others, like logical systems that can do the formal logic properly. The traditional classifiers, like decision trees and like logistic classifiers and like whole hundreds of classifiers, and grouping techniques and all of those tools, they will eventually come together. Hopefully with a language model kind of driving them all.
Are vector representations the same as vector embeddings, Podge?
Yeah. The idea is simple. Each word is represented as a point, and there is distance between those points. That's the idea with word embeddings. It may seem crazy simple, but it's not so obvious. Like literally, like for decades of computer science, this idea may have existed there, but nobody really pushed for it. People just assumed, okay, when we have a word, we assign an identifier to a word. For example, I don't know, a cat would be number this. And the AI system had to work with those discrete identifiers, which are very hard to process. They don't have these fuzzy properties that words have.
Ooh, okay, because I got confused.
Yeah, and nowadays almost everything seems, almost everything can be represented as a vector. You have vectors for images, vectors for words, vectors for whole books or movies, like recommendation systems. For example, they like to represent bigger pieces of media as a vector. YouTube videos were an interesting example because you can represent a YouTube video as a point in space, and then, similar videos would be close and different videos would be far apart. So this creates like a galaxy of videos. It's a really nice way of exploring the space. And it also makes it easier for machine learning to work. Do we have a navigator?
Wait, that big thing is cool. I didn't think of that.
I'm not sure if we can find this. Or maybe Wikipedia. So it's doable. It looks something like that. Like, give me a moment. Yeah, I guess all of them are similar, but you essentially have those clouds of similar content. It's nice for discovering new interesting places, because YouTube typically shows you only a part of its, galaxy, and I don't think we can find it, but it's possible to build something similar. TSNE is a typical. It's actually a very good page. This one here, Cola GitHub.io. Oh, it's a map of Wikipedia. So internally, Netflix and YouTube, they have very similar maps that they use internally.
Thanks, man.
Sure, sure. There is a lot of jargon around those terms. But fundamentally, it's all very, very simple. I mean, not very, very simple. Like when you combine 10 different techniques, eventually it becomes messy, but each of the techniques in isolation can be understood by anyone. Okay, I'm trying to follow this stuff. So we are packing the frame. So this is where rendering starts. Rendering happens, and here's what we get. We get this end flash first for both widgets. Okay, so we are inserting them both. Maybe instead of end flash, I should call this insert recording. Then we have this begin submit. I just changed the representation so that we can more clearly see what's happening. Okay, this actually looked good. Okay, so we are packing root widget, slow widget goes into overflow. So here is the summary of the frame. So we inserted recording for root frame, then slow widget. Then root widget finished. Then we are skipping waiting because there is nothing to do. Then we are packing new frame. We are only packing the root frame, root widget. So we are inserting the recording. This is strange that slow widget finishes before.
Wantoninity8 says,
How is it going, Mound?
Hey. Alright, pretty decent. I'm fighting Vulkan as usual. The last weeks have been continuous struggle with Vulkan. And now for some reason it really wants to wait for the slow widget to render before rendering the root widget. This should take much longer here. This slow widget should not appear here. Okay, maybe I'm putting those semaphores here, I'm not sure. Actually, this looks good now. It's very weird, it switches between this mode. And when I Alt-Tab, it sometimes switches back to this other mode. Very weird stuff. Okay, so our slow widget has no waitlist. That's good. If this will lock, then it means that we are theoretically, I should be able to disable this and it should still work. Now it should render the background widget forever. Okay, so we are rendering frames, 16 milliseconds now. And we are not blocking. Ah. So how is it that calling this suddenly makes it slower? Okay, I think I may know. So when we create these surfaces, we are grabbing this canvas recorder. Maybe I'm using wrong recorder here. I'm using the synchronous recorder. Okay, let's go to our frame. I think this could be caused by those surfaces. That should still work. It works. And the thing is, now we will select recorder. Yeah, I don't think we have any recorder here. I kind of need to set this image provider. Okay, now when I create a surface, I create this surface using the right recorder. Okay, we still have this lockstep execution. Those are different extensions. Okay, apparently we have two queue priorities. Queue family foreign. EOD code and code video queue. Queue optical flow. Huh. I wonder what's that. Very interesting. Okay, the thing is, we seem to be able to create more than one queue. This graphics queue. So we should be able to have multiple of them. So maybe the issue we are getting is that when we create it, we are passing the same graphics queue, the same graphics index. Be right back. I wonder, maybe I can call this multiple times. returned the same value twice. What is this? Okay, this page looks nice. It looks like a proper documentation finally. I haven't seen this before. Okay, so do I understand correctly that when we have a device, okay, it already has a queue selected. Okay. So we can ask for this custom queue description. Okay, so I could add this custom queue setup. Let's do this. Let's ask for as many queues as we can. Why not? Okay, here is a test and see how it works. Okay, I will just copy this. And we will edit it in here.
Patrick Nowak says,
Hey Merrick, what language is it?
This stuff, this is C++. Still, we're not changing the language. I guess this could really use some help. So this is family index, I guess. So this is a family index, and for each queue in this family we can specify a bunch of queues here. And nice, for each of them we can also specify a priority for this queue. Let's allocate all of them with priority 1. These compute queues we don't use, we don't need them. I will remove that. So here we have a queue family. It also has present support. I don't know what I'm doing. I guess I will add this custom queue setup. This will probably stop it from working. Oh no, somehow it still works. I wonder how. be so nice if this was documented in some way. Okay, so I provided my own queues, so it's my job theoretically to get the queues and queue indices. I would like to see how this is implemented. And this just moves the vector. Okay, so by default, it asks for one queue of every family. Okay, so I know how this works. And how does this... How does this get queue work? Okay, so calling this is... It's just a very verbose way of getting the index, which we already have, because we went through this. So we know that this I is the family index. I don't know. Okay, so this index here is more like an index of the family. Okay, that library that we're using, it's more complex than Vulkan itself. This website could use slightly better formatting, I think. Okay, I'm assuming that the graphics queue can also do presentation, so maybe I should check this explicitly. So this is actually index of the family. Let me add the comment. Should still work, hopefully. Yep. Now I want to copy this thingy, vking at device queue. Okay. Wow. Turns out Vulkan is simpler than this library. It was supposed to simplify it. Oh, or maybe not. It stopped working. Let me see without this. Okay, this is the get queue. Is first getting the index and then calling vk get device queue. And that index is 0. Okay, it's right next to destroy device. Okay, this function was not initialized somehow. Okay, now it should work. Wait. Okay, here's the thing. We will create a separate descriptor for our background context. And actually, I'm thinking maybe we should have context for every queue. That would allow us to really render in parallel. This is getting interesting, but I'm worried that if I do some crazy change, like make it really crazy parallel, it will probably it's a Pandora's box. It will open so many issues. Let's be gentle. Let's start with two queues, just two. I'm starting to like Vulkan. I know I'm kind of stuck here, but it's really nicely designed. what is the minimum number of queues? Okay, so it's possible that we can have just one queue. So let's do it like that. Okay, so it is possible for the higher priority queue to starve the lower priority. So this is exactly what we want. We want the foreground rendering to push all of the background rendering out of the way. Okay, so I'm creating all of the queues with high priority and the last queue with basically zero priority. And our widgets, so eventually we will schedule our widget rendering on all of the queues except the last one. And the last one is going to be reserved for overflow widgets. When I'm looking at Vulkan, it seems like I could even implement like something like Vulkan over the network. Possibly. Or not. Oh, that would be too much data. Because the idea with Vulkan, with those queues, is it's perfect. It's exactly what how I kind of imagine the parallel processing should work. Anyway. So here we are getting our background queue. Stuff should still work, but we still are using just the foreground queue for everything. So let's change that. Okay, and that was it. That was the big change. Now we should have two separate queues. I don't know if they will work together. Hey, it seems to work. The timing has improved. Now this still renders every 70 milliseconds, but this one is almost real time. I mean, almost 60 FPS. But it's still not 60, and it should be super smooth 60. Okay, so here's an example frame. Those are the widgets which have finished recording, packing route, this. So we're inserting those recordings, the root widget immediately finishes. And we don't have to wait for anything. Then we are packing just root widget. And it finishes immediately. And we pack it again. And during the next frame, it all finishes. I think I should add some, maybe, measurements about the rendering speed. The stuff that we are doing, it should help with Automat. We're actually using 2 queues now. I was actually thinking that Skia by default uses like as many queues as it can. It's a surprise that we have to manage them ourselves. Yeah, I think it's more snappy now. I don't see those... We used to have those sporadic jitter, now it's almost gone. I mean, completely gone. I don't feel it at all. The pixelation is very smooth. Wow. I think we may also avoid this busy loop now. When we wait for rendering to finish. Have this weird thing. So I guess we didn't need those semaphores because as long as we render everything using a single queue, it is ordered sequentially. Yeah, we just improved performance, probably quite a bit. Okay, I wanted to try this on Windows because Windows laptop is the slow one. I'm not worried about this. But okay, it feels nicer now. It is much nicer. I like that. I'm not sure if I would get any benefit from... I guess I would, because I'm using semaphores. I could render like so many widgets in parallel. Yeah, I think I should use all of the queues as much as I can. I'm trying to start my laptop now, so that I can see if this works on lower powered device now. So it's funny that so far we've been very clever about what we render, because we've been measuring the rendering time of each widget, and we've been very conservative about scheduling the rendering. But now we have that, so we have this clever scheduler plus GPU side priority. So even when we schedule some background job, the GPU can actually render this in background and yeah. And not slow the UI. It feels so nice. Oh. The downside is that sometimes when I'm manipulating an object, it's rendered using this overflow queue, so there is latency here. When I grab it and I move it, this is super responsive. But when I drag it here, I get like a couple frames of latency, like actually pretty significant latency. This is almost traditional GUI levels of latency. So I think objects that I'm holding in hand, or like if I'm interacting with some object, I think then I should probably prioritize it. Okay, let's switch to Windows. We here. It should appear in a moment. There we go. Okay. I think our renderer is very conservative when it comes to deciding how much tasks to take on. We could probably change that. We could probably add some more features to the renderer to make it faster. Okay, so on this laptop, I also have OBS running, so it's doubly difficult. Okay, we have to remove Skia. It was in first party here. This feels so nice. Finally, this jitter was kind of annoying to me. I actually wonder why our test, because we have this test case with very, very slow. With this fractal, not fractal, this noise, this ball of noise. That test doesn't run at 60 FPS still for some reason. Let me plan what we can do. So we have these nodes on rendering. Let's see, those things are still relevant. Okay, actually, we started with this and we are now here. So we've implemented everything we wanted to implement. And I'm thinking about what else we could do. What are the to-dos that we could still implement? So we could use all queues. So checking back here. I can also delete Skia from here. Yep. And that stuff can build. So this is one nice thing we could do. But I think even currently we are pretty good in terms of like parallelism. Possibly. Maybe more than one queue would be nice. Another thing we could do is maybe we could so there is also this threading situation. So if we created thread per queue, it's a nice model because a thread can perform operations synchronously with a queue, and the main thread is the one that controls the present queue. So this would be the one that is actually synchronized with the window display. With some sane limits. For instance, we could say that we don't want more than like 16 threads. And those threads, I guess they could do the recording and insertion and syncing if necessary internally. Another thing we could do would be overpacking the so we could track the slack. So whenever we finish rendering, we always have some like spare milliseconds that we could use to render more stuff. Because our current accounting is very simplistic, we are assuming that everything is executed sequentially, which is not the case. And also, we could have a nice FPS counter. No, something failed. Let me see. So I guess precompile context. Doesn't include the string. Yeah. Yeah, there is no string here. how to fix this. Should I just edit this file? Issue should be fixed. Kind of manually added the string include here. Okay. I have no idea what are those barriers, but things seem to work without them. Maybe Skia's managing them for me. I'm interested in Maybe something that could help me monitor the performance. Okay, this easy profiler looks decent. Yeah, we have multiple threads. We can mark timestamps here. Yeah, easy profiler looks exactly like what I want. And also this, like streaming over network, this is something I also wanted. Okay, basic. This frame pacing sounded interesting. Actually, frame pacing is also interesting. It's about waiting as long as we can before we actually render stuff to screen. Compilation has more issues. Interesting.
Low pass effect. Low pass effect.
I'm looking for cues. It should have some cues here. Okay, it said failed to create swap chain. So maybe, yeah, this device has just two Q families. First one has the graphics, and the second one is video encode. Which actually should be fine. Okay, there is just one graphics queue on this device. But there are two video decode queues. Oh. Okay, so what is wrong? Graphics queue index, present queue index should be perfect. So maybe we can do this. If we have more than one queue, then we will set this to 0. We are still failing. This is strange. Validate backend texture failed. It's nice that I have a device with 16 queues and a device with 1 queue. At least I can tune this thing to work on both extremes. Okay, there is also these global priority properties. I wonder what's that. So it seems we are actually creating the queues correctly. The error is elsewhere. It's in this validate backend texture. Okay, so one of those is failing. Yeah, we need debugger. And since we need debugger, we have to quit cursor and switch to VS Code, because for some reason only in VS Code the debugger works. This is going to take a while. Yeah, I think one of those, this color info is invalid. That's my guess, actually. Probably Windows uses slightly different format for its textures. If I understand correctly, this will allow me to make the whole device high or low priority in the system. Well, Compilation is still ongoing. So okay, all of those that we could do, and one that we have to is to fix the new crash on Windows with validate texture. I think after we do this, probably the most important is having a nice FPS counter, because knowing where we are spending the time, it's like the most important thing we can do. This will tell us what we have to optimize really, or if we have to optimize anything at all. This whole thing seems to be really fast now. Actually wonder, maybe we could create multiple devices then? That would probably create so many issues. Okay, the debugging is close to starting. It seems like my CPU is struggling. It is being launched. You know what? Maybe this is something I can debug offline, because I'd say we've been pretty successful today with this. Okay, so let's end the stream here. And I honestly think next week, since actually, I don't know. I think we should be adding more functionality to Automat, not working on this rendering engine. The rendering engine is a distraction. There is probably like a month of work here to make it, super nice. I think we should switch and do some more of the usability features. Like, it feels to me, for instance, that it would be nice if we had the ability to drag multiple objects at the same time. This is like one of the most annoying things right now, when I have this timeline. Quite often I would like to carry it together with the keys which are on top of it. So maybe this is something we could do. Yeah, that would help a lot for organization of this. Yeah. Alright, so this is it for this week. Responsiveness is much better than it used to, so I'm super happy with that. And next week we are doing some more quality of life thingies. Okay, see you next week. Bye bye.